Here's our problem for today. We have to find the volume enclosed by that planar region 3x plus 4y plus 6 equals 12 and the three coordinate planes. You start by drawing the coordinate planes z, y, and x. So these are our three coordinate planes, and now it's time to draw the actual plane. So the plane, you can draw it however you'd like. I'm just going to draw it like this. Okay, here's my plane. Just connect these two and voila, there's my plane. It's not perfect, but there it is. So now my plane encloses some volume underneath it, and we have to find how much volume that is, right? So you can imagine our plane encloses this this kind of a volume underneath of it, and we want to find how much that volume is, right? That's our job. So what we have to do is set up a double integral. So let's do that. So I'm going to start with my double integral notation. Here's my first, here's my second. First of all, I have to think about, do I want to integrate with respect to y, respect to x? That's the first choice I have to make. Second choice I have to make is, when I look at my region on the xy plane, do I want to integrate with respect to y and then x, or x and then y? So usually you want to do y and then x. I'm just used to that. So what does that mean? That means you're taking a vertical representative slice, a vertical representative rectangle, and that's slice dy, and you're moving it horizontally. That means you're moving it along dx. So maybe if you want to do it that way, you can say dy dx over here, and this right here, that's going to be your y bounds. This right here, that's going to be your x bounds. Your y bounds can or may be in terms of a function. Your x bounds have to be in terms of numbers. Okay, and here I'm just going to put z for now, since I don't have space anyway to put everything. So let's put z here. Okay, so what do we do now? We gotta, number one, figure out the bounds. What are the bounds for y? So to find the region on the xy plane, I'm going to set that this over here, the z value, to 0, because on the plane z is 0. So where's my, here it is. So to find the region R, here's what we do. Set z equal to 0. That means 3x plus 4y equals 12. And so now we have y in terms of x, and so y is equal to 12 minus 3x divided by 4. That could be our y bounds. So our y bounds can be from 0 to this, which is 12 minus 3x divided by 4. So from 0 to 12 minus 3x divided by 4. What else do we know? We also have to find the x bounds. So the x bounds are relatively easy. The x bounds are just from here, since we're sliding it across the x-axis. Oh, since my y-axis is this way, I've drawn my representative rectangle wrong. This is a wrong representative rectangle. Okay, so make sure, hopefully you guys don't make the same mistake. The representative rectangle for this specific case should look like this. Okay, it should be vertical, so it should be parallel to the y-axis like that. So that's my representative slice dy, and I'm sliding it across dx. So I just noticed that. Now I want to find, of course, my x bound. So here's my lower x bound, which is of course 0, and here's my upper x bound. What is that? That's when my y is 0. So when 3x equals 12, aka my upper x bound is when x equals 4. So my lower is 0, my upper is 4. And so now I just need to plug in the numbers, do the math, and let's do that. So I'm going to have my double integral here, my double integral from 0 to 4, and from 0 to 12 minus 3x over 4. And what is my z? Well, I have to express z in terms of x and y. So let's do that. I'm going to write 3x plus 4y plus 6z equals 12. So z is of course 12 minus 3x minus 4y over 6. So plug that in here. You're going to have 12 minus 3x minus 4y divided by 6. And don't forget your dy dx. And that's about it. Now you just plug it in the calculator and let's see what we get. Of 4. And that, ladies and gentlemen, is how you do a double integral volume calculation. Thanks for watching. We'll check it.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.